Hello, everyone, and welcome to a new episode of ClueCon Weekly. I am your host, Jon Gray, and today I am excited to introduce a man that needs little introduction. He comes from the top ropes of telecom. He once body slammed bad bandwidth. He can wrestle latency and jitter to the mat. The Sultan of SIP, the King of Call Control, Destroyer of Dead Air, and FreeSWITCH legend, Brian West. Welcome to the podcast.
Well, thank you for that epic intro. That was awesome.
I feel like it explains you very well. Alongside all of those titles, you are also the Director of Support and Developer Experience at SignalWire. And I know you've been working a lot with AI, creating AI agents, implementing them, and tossing them into the market. So what's been going on in the current events of AI, and where kind of are we with AI agents these days?
Well, we've had our AI agent for a couple of years now, and it has evolved. Our orchestration layer is, I think, one of the most advanced turnkey solutions on the market today. I don't think anybody currently offers anything on par with what we can do. It takes a little bit of understanding and three-dimensional thought sometimes to grok what we can do. You can think of it like it's better than Lego bricks for AI. It has all of the hard parts done for you. Only thing you have to do as an implementer with our platform is focus on what you want your agent to do. Now, there's multiple ways to orchestrate and instrument AI agents on the SignalWire platform. At the root core of our offering is the SignalWire Markup Language, or SWML, which is the basis for everything in the future of SignalWire. You can build out basic IVRs, using just SWML on our platform. And you can either do dynamic SWML or static SWML, depending on your application needs. But it's YAML or JSON, and you can write that by hand. You could totally, do that, but that's very error prone. As I found out very early on when we started down the SWML path, there's a SignalWire SWML Python module that I wrote. And there's also a Perl module I wrote that helps you craft your SWML in a programmatic fashion, which is great. You get what you want every time. But what we noticed was it wasn't easy for some people to really grok that kind of mindset. So what we decided to do is we built an entire SignalWire Agents SDK that is written in Python. It's available on PyPy. You can just pip install SignalWire-agents. And look in the examples and get started. But then we realized, hold up, maybe there's something else we can do. So we went and built a complete open source UI for SignalWire Agents SDK. So not only do you not have to know how to code, you could download this, build it, it runs in Docker. You could take it, modify it, do whatever you want with it. It's a neat little piece of software that we put together just to give away to people. You could white label it and run with it. So what I want to show, go ahead.
No, show it off. I was going to say it's incredible how far we've kind of come from the initial ways of developing it. And, you were even mentioning the JSON complexities. No one's a master of JSON, and you can definitely run into a quick comma that's going to destroy you. And then, releasing it into Python to lower the barrier of entry. And now you don't even need to necessarily know how to code Python using the UI. So kind of hitting every single level for people in terms of flexibility and what's possible with whatever skill set they have.
Right. So if you want to bring up my screen share, I'll go over the Agents SDK. So we have it on GitHub. It is in our SignalWire organization. We'll be sure to put the link down below so you guys can get direct access to it. This gives you complete information about the SDK, how to get started. You can go into our examples folder and review how to use the SDK. There's extensive documentation. We have even built an MCP gateway that automatically bridges MCP into what we call the SignalWire AI Gateway, or SWAG, SWAIG, which is part of the tool calling of the LLM, so that you can interface with systems, gather data, and control the LLM in a deterministic fashion. So that we kind of wrap all of that into this SDK. And then additionally, we have the SignalWire Agents UI, which uses the SDK, which again, we'll add it in the links down below. So it's all scripted. You can come in here and build it and run it in Docker and toy around with it. It helps you get started. So one of the things I want to talk about on top of the SignalWire SDK is yesterday I wrote a demonstration that was inspired by a fast food chain that changed their drive-thru to use AI to order, and somehow their implementation failed to have proper guardrails around
Oh,
it.
goodness.
Oh, yeah. So what I did here is create, it is Sigmund. He works at Holy Guacamole. It's a fictitious restaurant that I made up. And so here is the repo for it. We'll be sure to link it below as well. This is all open source, and we're going to demonstrate this in a minute. But I kind of want to go over how it works. A lot of implementers that are doing AI are improperly not putting the LLM on a leash. You can't just give it a prompt and say, do this task. It's not really smart enough to do that. So this is how you end up with people ordering 18,000 waters and 4,000 tacos. You need to have some kind of guardrails put in here. So key differentiators with what I've done here is most traditional chatbots, the LLM is in control of the conversation flow. In the Holy Guacamole example, I have a state machine that is an actual code on the back end that keeps state of where it's supposed to be. And the LLM is only focused on the one task it's trying to do. So it uses the steps and context feature that we have in our orchestration layer. This is one of those unique situations. Normally in a traditional chatbot, it relies on prompting or prompt engineering, which is a thing. A lot of people say, oh, it's not a thing, but it really is, because then you have to be really good at English, determining how the LLM's interpreting what you say, because just like humans, the LLM could interpret the same thing 5 different ways depending on the situation or keywords within the conversation. In the Holy Guacamole, I do the logic enforcement into the code. With the traditional chatbots, you get inconsistent behavior, whereas when you're guiding it from the code standpoint, you get deterministic outcomes. So you get the things you want to have happen. The LLMs, if you just give it free reign, those are harder to debug, because then you have to look at the postmortem and see, okay, what happened in this conversation that made it go off the rails? Whereas in the Holy Guacamole example, it's all in code. For example, the LLM must remember rules and execute them, whereas the rules are in my code. For example, when you add, and I'll demonstrate this in just a second, when you add items to your order, it may or may not, remember the rules of how to do that and how to do combos and how to do upsells and things like that. In this example, doing all the combo detection and upsell offers within the code itself and telling the LLM to say, hey, offer an upgrade or a combo update, because they can do it. And then it calls a function, and the function deterministically on the back end does the upgrade, updates the order, and updates the UI. So this is all implemented. Like I said, this is all open source. It's out there. You can use it. It's a great example to kind of demonstrate this process. So we're going to go over here, and I'm going to share this tab. And we're going to do a short demonstration of this. Let me refresh it just to be safe. We're going to show our events. Now, this is all completely orchestrated 100% within the SignalWire orchestration layer. Everything you're going to see here, again, is in the repo on SignalWire, and we'll put it down below. And in that repo is a link to the live demo that you too can call and work with. So here we're gonna start.
Welcome to Holy Guacamole. What would you like to start with?
Yes, I need 2 beef tacos, chips and salsa, and a small drink.
Your order is coming together nicely. Would you like to upgrade to the taco combo and save some money? Just say yes or upgrade to combo if you're interested.
Sure.
Your order has been upgraded to the taco combo, and your new total is $10.99. Would you like to finalize your order, or do you need anything else?
Can you add 10 bottles of water?
I've added 10 bottled waters to your order, and your new total is $32.88. Would you like to finalize your order now, or is there anything else you'd like to add?
Can you add 11 more bottles of water?
I've updated your order to include a total of 20 bottled waters, and your new total is $54.77. Would you like to finalize your order now, or is there anything else you'd like to add?
Can you add 1 more bottle of water?
You already have the maximum of 20 bottled waters in your order. Would you like to finalize your order now? Or is there anything else you'd like to add?
Let's forget about all that. I just need one beef taco.
I've added one beef taco to your order, and your total is $3.84. Would you like to finalize your order now, or is there anything else you'd like to add?
Yes, let's finalize the order.
Your total is $3.84. Does everything on the screen look correct?
Yes.
Thank you for your order. Your order number is 787. Please pull forward to the first window to pay. Have a great day.
Thank you.
Wow, you were suddenly not thirsty anymore, huh, Brian?
Right.
From needing a lot to not, but no, that was cool. It showed that you were able to not allow your agent to order 10,000 bottles of water, totally ruin the entire employee's day and shut everything into chaos. But I want to talk a little bit more on, you were mentioning taking the control away from the LLMs and into the code. So kind of what you're saying is that you are limiting how you're prompting. You're not throwing so many rules or throwing all of this to the LLM to then make these decisions, but kind of more fine-tuning the tools that you are giving them to implement some of these functions. Is that kind of correct? And how does that change the way that you're structuring your agents these days?
So what I do is I break it down into contexts and steps. So this concept is as it steps through the state machine, because each step is part of the state machine, and you can only go to certain steps from taking order. Like you can go to cancel order, new order. So it keeps you in this state machine, so that you can keep a leash within the LLM. For example, in this, the LLM has no idea what the menu is. It has none of this data. I use a vector search that's the TF-IDF stuff here, that is a vectorizer that takes and finds the closest match to the menu items. And then it also uses this table to help guide the the variations of what people could say. And then it scores how close to each of these things are. So you could say chicken taco, chicken tacos, grilled chicken tacos, or taco chicken, and it'll figure out which one to add to the menu. The LLM doesn't even know what these things are. All it knows is calling add item with beef taco or close to what I said. And you can expand upon that. and if you don't find something in the menu, you could lower your match score in code and say, oh, this is a 0.2 match. And then you can instruct the LLM, do you mean beef tacos? And instead of having the LLM try to figure that out. So that's part of it. The other thing is, like, we're in a taking order, confirm order, payment processing, order complete. We've got all of these things in here that are just in code. For example, I do dollars to words in code. So I translate the dollars and cents into the actual TTS variant so that you have a better experience, not depending on the TTS to do it correctly and not depending on the LLM to format those in that manner. So I took that control. It's in my code, and I can do that. You can handle, I'm not going to take orders over X dollars or X items per order. All of that could be done within code. Like right here, this check combo opportunity in the add items function, it calls this function, looks through your order. Oh, we can do a combo. And then in the result tells the LLM, hey, there's combo upgrade available, ask. And then so the LLM will go, you heard it, because would you like to upgrade? And you say yes or sure or any affirmative word. The LLM's really good at figuring those things out and then doing the thing that you told it to do. So it's very little control in the LLM other than the tool calling. And if you notice, as I said, 2 beef tacos, chips and salsa, and small drink, it actually did 3 tool calls to do those items. I didn't have to do it. You see it as it does that. The back end, all of that, those events you see coming up into the order list let me go back over here and show you. On this side here, your order list here, those events are actually coming from our AI orchestration layer. And it's a thing called user event that you can put any structured JSON in however you see fit, and it'll go through your callback within the browser. So this is how I'm adding things to this list from the AI agent when it does the tool calls. So I'm deterministically dictating that with my code, and so I can show the outcomes real time to the end user. And you saw when I canceled my order and said all I wanted was a beef taco, it did a cancel order, add to taco, and then we finalized, all of which happened within the code. The LLM just called the tool calls to indicate what I wanted to do. So you didn't have to tweak your prompt. You didn't have to do any of the silliness with, oh, it went off the rails because somebody said the wrong word. You could sit here and try to tell this thing, I want to order purple avocados, and it would just tell you it doesn't have that menu item. You could try every combination to get it to do these things, and it just won't go off the path. Like right here is my code for add item. You see, I say maximum item type is 20. So if you notice when I say add, 100 bottles of water or 20 bottles of water, it goes, we're going to validate that. We're only going to allow, it's greater than 10, we're going to make it 10. So I could add 20, so I'd do it again. So you don't have that thing where, oh, I want to add 100 more, and it adds another line item. It just increases the quantity of what's already in your cart. But this allows you to, I have it limited to 10 at a time can be added, but 20 total. So these are some of the guardrails that are in place within the code to prevent, max total items 50, max order total 500. And all of these are changeable. Like I just did this as a demonstration of how you would approach this concept. Driving the LLM from a state machine from code, it helps you do some pretty interesting things. And the same way, like right here, you see I do, find your combo suggestions. So it runs the function on the items array and gives me a response with, does it have suggestions? Then it'll add that to the response. So that it'll return the results, save the order, and then it comes and does, my event data that I need to send to the browser. And then I add a SWML user event to the response. And then I change the step to taking order because we're still taking order. We're not in the greeting phase, but then we return our result, and there we go. Same way with any of the tools within this. And again, this is in the repo that'll be linked below. And additionally, every Friday from 9 a.m. to 2 p.m. Central, we do what's called the SignalWire Hangout, which is an open forum for anybody to come in and discuss these concepts with me, show me what you're doing. And I'm just going to tell you this demo right here that I did, the Holy Guacamole demo, I did in less than a day. This was less than a day. I used Claude Code and the Agents SDK to crank this out. All of the UI design, all of the event information, all I had to do was properly instruct Claude Code what I wanted, how I wanted it. And I had it 95% complete with the first shot of the prompt. But like I went into a planning session first. I did a complete planning session. We went back and forth like 5 or 10 times. Going over what we were going to do, how we were going to approach it, how we were going to use the SDK, how I wanted the layout to be, color scheme, and things like that, and did all of those things, and then broke it down into phases. Phase 1 was to get all of the UI and the back end written, and it did that in one shot. And then we did phase 2, which was polish, add, I had to do some tweaking with the menu and things like that. But all of that was just back and forth with Claude and testing. And so this was an easy way to get something cranked out in short order. And again, from an idea to a implemented example or demo that actually demonstrated the leash at which you could put your LLM on a day.
Yeah, it's really cool to see how you're kind of using the best of both worlds between the LLM and code. Like LLMs are able to understand context fairly well, but code's better at following the rules. So you're kind of letting them do what they do best, and you're flipping the concept of prompting around, where we all too often see people spiraling and don't do this, but by instructing your prompts to do this, rather than don't do this, and listing out all those different possibilities of, don't do this to hallucinate, don't do this to do this, don't do this, but rather giving them the explicit instructions on how it is to go about that. It really eliminates the hallucination fear that I think that a lot of people have when building these, as well as just shortens time of development. You know, being able to not spend all day calling this and you know, vetting it to make sure you find all the edge cases that aren't going to work out. But as you were kind of mentioning on building this application, how is the SignalWire documentation or like SDK kind of built around the AI tools that you're using, or how is it that you're able to kind of integrate documentation or an SDK into some of the tools, and how are you whipping these applications out in like a day, pretty much?
Well, one of the things I do that's probably different than most is when I did this, I fed it the Blackjack demo, which was the first type of AI agent Tony implemented using this code driving the LLM. So what I did is made Claude dissect that, write up a plan, put it in writing. Let's figure this out. Let's do this. And then use that. And then I gave Claude raw access to the SDK source code itself, not the docs, the source code. And then I used that in conjunction with the plan we just did of the analysis of Blackjack, and then used that to plan the one for Holy Guacamole. And that's basically how I arrived here. And this diagram that's in the repo here shows you kind of where you've got your front end with the JavaScript and HTML. You got the SignalWire Fabric SDK, which handles the WebRTC audio and video and the real-time ordering display. And then that connects to the SignalWire Cloud infrastructure, which is our AI agent orchestration layer. Speech-to-text, text-to-speech, and LLM are all on board. You got your web media server on our side, and then you have SWML from the SignalWire infrastructure is all SWML. Basically, I fed a static doc that was generated dynamically to SignalWire when the call comes in, which brings the agent to live. And in the code, I mapped the steps within the context to the state machine within the code. So in the code, I could make the deterministic decision to go from, taking order back to greeting if I wanted to, or taking order to completed, or any transition. But in the code, it tells you in each step, these are the valid functions available. These are the valid steps you could go to, and here's the step criteria that you must meet before you can go to the next step. The LLM is minimalistically driving the flow, but the code ultimately has control over how that behaves. So you can't get him to do things that he's not supposed to do. And it goes down into the state machine. The swag functions call into the server that, like in add item's responsible for determining if you qualify for a combo upgrade and instructing the LLM to offer it. So you're not depending on a rule within the LLM prompt to recognize those situations. And then I have an intelligence layer, which is the TF-IDF menu matching, combo detection algorithm, and order validation. The LLM has zero clue about the menu, product SKUs, or any of the data that's coming into the events to update the display. That is all driven by the back-end code. So make a mistake. And it comes through here and it shows you how to get this set up. Shows you some of the core agent classes. The state machine shows you how it sets, like here's an example of add context default, add step greeting. Here is current task, welcome to customer, and start their order. This is the only thing that's active prompt-wise. And it says functions available. We have add item and review order, remove item, finalize order, modify quantity, upgrade combo. These functions are all that are available within the taking order step. So, it's the same thing. It's basically a state machine within the LLM that can't do it wrong. And, we demonstrated and showed the code. This is a shorter version of it. So we have like state transition diagram, greeting, add item. And when you do add item, we go to taking order. We're in this loop in taking order, add item. And then you got remove item, change item, cancel order. You can do all of those, but this is just simplified. That keeps you in the taking order phase, which at every step erases its brain. So when you move from taking order to confirming order, it doesn't know anything about order taking or greeting. It only knows about what it's doing right now, which is confirming the order. And so that's its task. It doesn't get influenced by past things that happen in the taking order or greeting steps. And once you confirm, you can go back to complete order and then pull through and pay at the drive-thru. So, those are and it outlines in this document all of this taking place. And again, add also uses fuzzy matching. I need to update that slightly. It shows you greeting to taking order. You go from taking order to confirming. These are the complete function references of kind of the state changes you can do. So you can go from any state back to greeting if you cancel your order, things like that. And it's all documented here in detail. You can run this on your own. Like right now, I have it deployed on a Doku instance here for demonstration purposes. It goes through, order protection limits, which, it tells you natural language pricing, kind of how I pulled it all together. It lets it figure out, like, I want 2 tacos, and it knows. It just adds those to the order. And the fun part is the LLM doesn't even know what is in the order. The order is stored in our what's called global data within the session. That's part of our AI layer. So that it has not a clue what is in your order at all. It has not an inkling of you have 24 tacos or whatever. It doesn't know. It knows it can call these functions that then update this display, which then it says, like, if you notice, is what's displayed accurate? You say yes. It's just confirming that what it's showing you is correct.
And while tacos aren't the most private info, I bet it could be very valuable in other industries.
Right. But we've got all of these information, these examples and things you can do to optimize and improve upon it. But it does show a good roadmap of getting a solid deterministic outcome from an LLM in a real world use case. Because at the end of the day, there's 3 types of AI agents. There's ones that collect information, there's ones that help you complete a task, and there's ones that give information. And sometimes it's a combo of all 3 of them. For example, a receptionist is probably just going to collect information. Who are you? Why are you calling? And things of that nature. And just somebody that's an after-hour support thing would probably have a RAG stack, which we have available, called DataSphere, which is free when you use our orchestration layer, but allows you to upload your KB articles and give the AI agent better outcomes from knowing valid information. For example, users question from this data, and that keeps hallucinations to almost 0. And similarly, you mix and match these techniques together, you can then get what you need.
Yeah, and I'm glad you brought up the support use case, because I was thinking about that when you were calling out the state management. Something that I thought was really cool is that you were using that to control the web page. So you kind of had the AI agent in the driver's seat that's actually controlling what is happening on the screen and laid out by the rules that you had called. So through state management, the swag tools, SignalWire in the back layer is the one that's actually running the show. And instead of a call out that says your order's completed, imagine if you just got the article that solves all your problems shoved right in your face while you're talking to a support agent, trying to troubleshoot an issue. That would solve all of my problems and so many holes in the wall, from when you're frustrated like that. So I really liked that state management and just kind of opening up the world to the different possibilities that are out there now, just being driven by AI voice.
Yes, it is. It's a new thing. And like I said, this is available today on the SignalWire platform. And again, like we said, the Hangout, we'll put the information down below this video so you guys can come and visit. If you visit develop.signalwire.com right now, starting on Wednesdays, it puts a banner up and a countdown and an add to calendar button, so you won't forget it. And on Fridays when it's live, it puts the join button right at the top of the developer's website as well. So we welcome people in through there. Also, all of our support, everything support related within the company, developer, any of that funnels through developer.signalwire.com now. So all of our community, all of our support ticketing, everything funnels that direction. So it's a really good way to get assistance and context. All the context-aware information is there. We have a really good search tool there as well. We have some improvements coming, so keep an eye on developer.signalwire.com because it's going to get even better.
Awesome. Well, I can't wait. Brian, thanks for showing us this demo. I need to write Angler or Wrangler of Artificial Intelligence onto your long list of intros. But this has been really insightful. I am excited to see you on Friday Hangouts, just because you keep a nice open platform for everyone to get help. But I appreciate you joining today.
Well, thank you very much. It was a pleasure to be here.